For the solution, we have beta plus theta is equal to 60 degrees. And that's our equation number 1. Then we have Rx is equal to summation of f of x is equal to r. We have 200 cosine theta plus 240 cosine beta. This is our equation number 2. And for Ry, we have summation of f of y is equal to 200 sine theta minus 240 sine beta. And this is our equation number 3. We will now substitute equation number 1. We have 200 sine theta minus 240 sine of 60 minus theta is equal to 0. Simplifying the equation, we will have 5 sine theta minus 6 quantity sine 60 times cosine theta minus cosine 60 times sine theta equal to 0. We will now have the value of theta, which is 33 degrees, and for the beta, which is 27 degrees. Substituting the values to equation number 2, we have r is equal to 200 cosine 33 degrees plus 240 cosine of 27 degrees. We will now have the value of the resultant force, which is 381.58 pounds.
Using sine law, P divided by sine 71.41 degrees is equal to 2000 divided by sine quantity 18.59 plus alpha. Optimizing dp over d alpha is equal to negative 2000 sine 71.41 degrees cosine quantity 18.59 degrees plus alpha all over sine squared quantity 18.59 degrees plus alpha, which is also equal to 0. Negative 2000 sine 71.41 degrees cosine quantity 18.59 degrees plus alpha all over sine squared quantity 18.59 degrees plus alpha is equal to 0. The constant in the numerator and the denominator cancels out. Cosine quantity 18.59 degrees plus alpha is equal to 0. 18.59 degrees plus alpha is equal to 90 degrees. 90 degrees is from the inverse cosine function of 0. Alpha is equal to 71.41 degrees and gamma is equal to 18.59 degrees. P is equal to 2000 sine 71.41 degrees all over sine 90 degrees, which is equal to 1895.65 pounds. R is equal to 2000 sine 18.59 degrees all over sine 90 degrees, which is equal to 637.59 pounds.
this problem, we are required to find the alpha and the theta. We first solve the problem using equilibrium equations. For the summation of f of x equal to 0, we have 0 is equal to 40 minus 20 cosine alpha minus 30 cosine theta. Simplifying the equation, we have 0 is equal to 4 minus 2 cosine alpha minus 3 cosine theta. That's equation number 1. For the summation of f of y equal to 0, we have 0 is equal to 20 sine alpha minus 30 sine theta. Simplifying the equation, we have 0 is equal to 2 sine alpha minus 3 sine theta. And that's equation number 2. From the figure, we have sine theta is equal to 2 sine alpha over 3. Cosine theta is equal to the square root of 9 minus 4 sine squared alpha over 3. We now substitute the value of cosine theta to equation number 1. We will have now the value of alpha, which is 46.57 degrees. Substituting the value of alpha to equation number 2, we have 0 is equal to 2 sine of 46.57 minus 3 sine theta. We will now get the value of theta, which is 28.96 degrees. For an alternative solution, we will use the cosine law and sine law. Using cosine law, we have 30 squared is equal to 20 squared plus 40 squared minus 2 times 20 times 40 cosine of alpha. We will now have the value of alpha, which is 46.57 degrees. Using sine law, we have sine theta over 20 is equal to the sine of 46.57 over 30. We will now have the value of theta, which is 28.96 degrees.
Required in this problem is the distance x. Solution. Using the equations of equilibrium, summation moment at A, clockwise positive, is equal to 0. 200 times 3 plus 100 times quantity 12 minus x minus reaction at B, cosine 45 degrees times 12, is equal to 0. Summation forces vertical, upward positive, is equal to 0. 1800 minus 100x minus 6 square root of 2 times reaction at B is equal to 0 will be our equation number 1. Summation forces vertical, upward positive, is equal to 0. Negative 350 plus reaction at A, cosine 30 degrees, plus reaction at B, sine 45 degrees, is equal to 0. will be our equation number 2. Summation forces horizontal positive to the right is equal to 0. Reaction at A sine 30 degrees minus reaction at B sine 45 degrees is equal to 0. RA then is equal to reaction at B sine 45 degrees all over sine 30 degrees, which will be our equation number 3. Substitute equation number 3 to equation number 2. Negative 300 plus reaction at B sine 45 degrees cosine 30 degrees divided by sine 30 degrees plus reaction at B cosine 45 degrees is equal to 0. Reaction at B is equal to 155.29 pounds. Substitute the value of reaction at B to equation number 1. 1800 minus 100x minus 6 square root of 2 times 155.29 is equal to 0. Distance x is equal to 4.82.
In this problem, we are required to find the support reaction. To solve the problem, we will first isolate member DE by summation of moment at T equal to 0. We will have 10 times 3 times 3 halves minus RE times 3 is equal to 0. We will have the value of the reaction at E, which is 15 kilonewtons. By summation of forces horizontal equal to 0, we will have the horizontal reaction at D is equal to the horizontal reaction of B and to the horizontal reaction at A. And by summation of forces vertical equal to 0, we will have negative 10 minus 10 times 3 plus 15 plus RdV is equal to 0. We will have the value of the vertical reaction at D, which is 25 kilonewtons. We now isolate section BD. By summation of moment at B equal to 0, we have RdV times 3 minus RC times 1 is equal to 0. Since RdV is 25, we have 25 times 3 minus RC times 1 is equal to 0. We will have the reaction at C, which is 75 kilonewtons. By summation of vertical forces equal to 0, we have negative RBV plus RC minus RdV is equal to 0. We will have the vertical reaction at B, which is 50 kilonewtons. We now isolate section AB. By summation of forces vertical equal to 0, we have negative RAV minus 5 plus 50 is equal to 0. We will have the vertical reaction at A, which is 45 kilonewtons. By summation of moment at A, we have 5 times 1 minus 50 times 2. We will now have the moment at A, which is 95 kilonewton meter.
Required in this problem are B horizontal, B vertical, reaction C horizontal, reaction C vertical, reaction E horizontal, and reaction E vertical. Solution: isolate pulley. Summation forces vertical positive upward is equal to 0. A vertical is equal to 600 pounds. Summation forces horizontal positive to the right is equal to 0. A horizontal is equal to 600 pounds. Now, isolate member DBE. Summation moment at E, positive clockwise, is equal to 0. Negative 600 times 16 plus B horizontal times 6 is equal to 0. B horizontal is equal to 1,600 pounds. Summation forces horizontal positive to the right is equal to 0. Negative 600 plus 1,600 reaction at E horizontal is equal to 0. Reaction E horizontal is equal to 1,200 pounds. Considering the whole system, summation forces vertical positive upward is equal to 0. Negative 600 plus reaction E vertical minus 600 is equal to 0. Reaction E vertical is equal to 1,200 pounds. Considering the whole frame, summation forces horizontal positive to the right is equal to 0. Negative reaction E horizontal plus reaction C horizontal is equal to 0. Reaction C horizontal is equal to 1,000 pounds.
We are required to find the weight to start the system. To solve the problem, we will first isolate block A. By summation of f of y equal to 0, we will have the normal force which is equal to 600 pounds. And by F equal to the coefficient of friction times the normal force, we have 0.1 times 600. We will have the value of the frictional force which is 60 pounds. And by the summation of f of x equal to 0, we have t1 minus f equal to 0. We will have the value of t1 which is 60 pounds. Next, we isolate block B. By summation of f of y equal to 0, we have negative 400 cosine 30 plus n is equal to 0. We will have the value of the normal force which is 346.41 pounds. By F is equal to mu times n, we have 0.1 times 346.41. We will have the value of the frictional force, which is 34.64 pounds. And by summation of f of x equal to 0, we have 0 equal to negative 60 plus t2 minus 34.64 minus 400 sine of 30. We will have the value of t2 which is 294.64 pounds. We will now isolate block C. By the summation of f of y equal to 0, we will now get the required weight which is equal to 294.64 pounds.
Required in this problem is force P. Solution: isolate block 2,000 pounds. Summation forces horizontal positive to the right is equal to 0. Negative reaction at A, sine 15 degrees minus 500 plus reaction at B, cosine 15 degrees is equal to 0. Reaction at B is equal to 500 plus reaction at A, sine 15 degrees all over cosine 15 degrees. Summation forces vertical, positive upward is equal to 0. Negative 2000 plus reaction at A cosine 15 degrees minus reaction at B sine 15 degrees is equal to 0. Negative 2000 plus reaction at A cosine 15 degrees minus reaction at A sine squared 15 degrees plus 500 sine 15 degrees over cosine 15 degrees is equal to 0. Reaction at A is equal to 2,380.14 pounds, while reaction at B is equal to 1,155.39 pounds. Now, isolate block P. Using sine law, P over sine 45 degrees is equal to reaction at P over sine 60 degrees. P is equal to 943.37 pounds, and that is our final answer.